Hi everyone, we're going to be talking about the lab for this weekend, and this is going to be your first lab book lab, so it's going to require two forms of evaluation. The first is you're going to write it up in the lab book. Please refer to the video that I've posted about lab books. This will be the first experiment that goes into your laboratory notebook, and then it will also require a formal lab report. And I'm going to post a video about formal lab reports and a sample formal lab report for this experiment. So we're going to do this one as an online simulation. And the web page that I'm at is called the Chem Collective. And when you put chemcollective.org into your browser, this is the page that's going to come up. And what I want you to choose here is oxidation, reduction, and electrochemistry. And when you do that, you're only going to have two choices. You're going to choose exploring oxidation and reduction reactions. Now, there is a set of tips that you can go through and you can watch. I recommend that you do watch those. This is your basic laboratory bench for virtual labs. Now, you're going to need some solutions today. You can click on solutions, you can click on glassware, you can click on tools, okay? The solutions are outlined in the procedure. We will start out with, let's start out with the copper nitrate. And I am going to add 4 flasks of copper nitrate. And when you add them, you will see over here on the far right, the last one I added, that it is outlined with this kind of dotted line. And over here on the left, we have information. And it's telling you the name and concentration, 0.1 molar copper nitrate. It's telling you the volume and the concentration of all the species. Now, since it's an aqueous solution, dissolved in water, you have got hydrogen ion and hydroxide ion to about 1 × 10⁻⁷ concentration in molarity. Not a whole lot, but it is present. The copper 2+ ions are 0.1 molar. The nitrate ions, of course, would be 0.2 molar because there are 2 nitrate ions for every copper ion. Now, pH is 7, temperature is 25 degrees. You get the idea here, okay? Now, next thing, I'm going to go back and click on stockroom again. I'm going to go to solids. Now, I am going to choose copper, zinc, lead, and magnesium. Now, this is going to represent 1 row of the data table. As it shows in the lab. Now, I'm not remembering if this is the exact order that I had it in the data table or not, so don't hold me to that. Now, what I want to do is add some of the metal into the solution. Now, you've done this before in honors, putting metals into microplates inside of solutions. So what we do is we grab the bottle. I've put the cursor on the bottle and I move it until the flask is highlighted. Now it says, how much do I want to put in? Now I'm going to do a precise addition. I could also do sig fig, more realistic, precise. Every time, let's use 2.0 grams. Pour it in and then close the bottle. Okay, now it has gotten moved. That happens. I'm going to bring that down there. Okay, now I'll do the same thing for zinc. Into the next flask, I'll add the exact same amount, 2.0. Okay, I'm going to pour. Close the bottle. I'll bring that down here. Lead, I'll put that in there. 2.0, pour, close by clicking on the X, bring it down here, and then the last one, I'm going to pour a copper metal into the copper, 2.0 grams, pour, close this up. Now, interesting to look at these. First thing that I'm seeing is that this last flask where I poured copper into the copper is still blue. And when I click on it and I go over here on the left side of the screen, I see that I still have 2.0000 grams of copper. And the concentrations of everything else haven't really changed, although the volume went up to about 51 milliliters. So I'm going to mark that down as no reaction. Click on this one where I put the lead in. Now notice the amount of lead went down. I know that I added 2 grams, but I'm now down to 0.96 grams. Don't worry, you don't need to write that number down, but you can cite that as evidence of reaction. Also, I now have copper metal, which was not present before. I had copper ion. Remember, one of the pre-lab questions is, what is the difference between Cu and Cu2+? Okay, so boom, I have evidence of reaction. The color is no longer blue. I've decreased the amount of copper 2+. I'm pretty willing to say, based upon this number up here, copper 2+ is now basically 0. If I have 10 to the -7 molar of something, that's 0. I don't have any left. Okay, now, also the volume went up a bit to 50.61 milliliters. Now here, where I added the zinc, notice the amount of zinc went down. It was 2 grams. It's now 1.67. There's evidence of reaction. And the amount of copper went up. There's evidence of reaction. The color changed. There's evidence of reaction. Here, where I added the magnesium to the zinc, okay, the amount of magnesium went down. The amount of copper went up. The amount of copper 2+, it's saying basically 0 this time, okay? And for this one, basically 0. For this one, I had an itty bitty little bit left over. And this one, I basically had all of it left over. So what I can do is use this essentially to talk about an activity series. I can say that in this case, the magnesium was about the most reactive metal. Okay, the zinc, the second most, or pretty close to magnesium's reactivity. Lead, not quite as reactive, but still pretty darn reactive. But of course, copper's not going to react with copper 2+ because they are the same thing. Now you're going to go and do 3 more identical experiments beyond this one. You'll do this one, and then you'll do 3 more, okay, to represent all 4 lines that are in that data table, okay? And I'm not looking for you to record any numeric values in your data table. I'm looking for evidence of reaction, and I want you to essentially rank which metal was the most reactive and which metal was the least reactive, and we're going to use that to create our own activity series. Okay? Now, a couple other things that are important to know. Up here on Edit, I can go through and remove a solid, remove a liquid, etc., but I like this one. Clear the workbench. I've got a nice fresh workbench. I can start over again. Okay, so really important. This is the Chem Collective website, okay? And that's the one that I'm going to be directing you to for a lot of labs this year, okay? On the Chem Collective homepage, we chose specifically oxidation, reduction, and electrochemistry, and we chose exploring oxidation reduction reactions, and that was where we started this experiment. Okay, I hope you have a good lab, and if you have any issues, feel free to send me some questions via Schoology. All right, this is Morgan, signing off.